All right, everyone, get ready, because today we are tackling the Big Bang.
Diving right in, always a fun one.
We got a ton of requests from you all to dig into this whole universe-starting business, so we're taking a deep dive with, what else? Big Bang for Dummies.
Classic. Never underestimate a For Dummies book. They're great for a reason.
Totally. So, Big Bang, right. You'd think it'd be simple, like just a big ol' explosion and bam, universe.
Yeah, the name kind of conjures up an image of fireworks or something.
Right. But it's not that straightforward, is it?
Nope, not at all. It's more like, imagine everything, and I mean everything squeezed into a space so small you wouldn't believe it.
Smaller than a breadcrumb. Smaller than a grain of sand.
Way smaller. Think tinier than you can even picture. The article says like a speck smaller than the tip of a pen.
Okay, now my brain's hurting a little. That's unimaginably tiny, and that little speck contained what, all the stars, planets, us.
Everything. All the matter and energy that makes up everything we can see and even can't see today, all crammed in that tiny speck.
Wild. But it wasn't just squished together, right? It was also like super hot.
Unbelievably hot. Like hotter than anything we can even fathom. Dense and hot beyond measure is the only way to even describe it.
Okay, so we've got this teeny, super dense, crazy hot speck of well, everything. Then what? How do we go from speck to universe? That's the million-dollar question, right?
Exactly. And that's where the bang part comes in, but not like an explosion into something else. More like space itself expanding super fast outward in all directions at once.
Okay, the book compares it to a firework, which makes sense visually, all that energy blasting outward.
But a better analogy, and one they use, is actually raisin bread dough.
Ah, yes. I like that one. Expand on that a little. Help us wrap our heads around this.
So imagine you've got a lump of unbaked raisin bread dough. The raisins are like galaxies, right? Now, as the dough bakes and expands, those raisins spread further and further apart.
Right. Even though they're not moving on their own, the dough expanding pushes them apart.
Exactly. That's what's happening with the universe.
Yeah.
It's constantly expanding, pushing those galaxies, those raisins further apart. It's still happening even as we speak.
That is mind-blowing. But, okay, how do we know any of this is true? It's not like we can hop in a time machine and go, yep, there's that tiny speck. Taking notes.
I know, right? If only. But luckily, the universe is pretty cool and tends to leave evidence behind, like cosmic breadcrumbs.
I like it. Cosmic breadcrumbs. So what kind of breadcrumbs are we talking?
Well, one of the biggest ones is something called the cosmic microwave background. CMB for short. Think of it like, remember the heat inside your microwave after you make popcorn?
Oh, yeah, you can feel it even if you don't open the door right away.
Right, so the CMB is like a faint afterglow of heat left over from the massive amount of energy released during the Big Bang.
Wow, so we can actually detect this ancient heat. That's pretty convincing evidence.
Definitely. It was a huge discovery, especially back in the 1960s when it first happened, really solidified the Big Bang theory. But it's not the only evidence, of course. We've also got something called redshift.
Redshift, yes, the book mentioned that one. Something to do with light, right?
Exactly. Basically, light from distant galaxies, it looks redder to us because those galaxies are moving away from us.
So wait, just like sound changes when, say, an ambulance siren is moving away from you, it gets lower pitched?
Perfect analogy. Same principle with light. As the galaxy moves away, the light waves stretch out, shifting towards the red end of the spectrum, hence redshift.
That is so cool. Okay, so we've got the afterglow of the Big Bang. We've got the way light acts from faraway galaxies. Anything else that supports this theory?
Well, there's the fact that the universe is full of specific light elements, like hydrogen and helium, and the amounts, they match perfectly with what the Big Bang Theory predicts should have been created in those first few moments.
It's like a giant puzzle, and every piece we find fits perfectly with the Big Bang. Amazing. So to be clear, this all supposedly went down, what, almost 14 billion years ago?
Around 13.8 billion years, yeah, give or take. Hard to wrap your head around that kind of time frame, isn't it?
Absolutely. It's like saying a really long time ago just doesn't cut it.
Yeah.
But it's not even just about how long ago it was, right? You were saying earlier that the Big Bang is when time itself began.
Exactly. The idea of before the Big Bang gets really tricky, almost meaningless, because as far as we know, time as we experience and understand it started at the moment of the Big Bang.
Whoa, now that is a mind bender. Okay, so 13.8 billion years. Think of all that's happened in that time. Stars are born, they die, they explode, they make new stars, galaxies form, and here we are, just a tiny part of it all, on this little planet orbiting our sun.
It boggles the mind when you really think about it.
Yeah.
And it makes you wonder, right? The universe is still expanding, but what does that mean for the future? Will it just keep going forever?
No, that is the ultimate question. And unfortunately, Big Bang for Dummies doesn't seem to have the answer to that one.
Maybe a topic for another deep dive.
Definitely. There are so many theories about the fate of the universe, and who knows, maybe one of our listeners will be the one to figure it out. But for now, I think we've all had enough mind-blowing cosmic revelations for one day. Until next time.